Anton, you have 50 minutes. Take it away.
Right. So thanks a lot, Dan. Thanks everybody for coming. So I'm a postdoc from Mannheim, and I'd like to present a joint work with my colleague, Nicholas Schutz, who is also in the audience. This is an ongoing project, so it's quite preliminary. So we're currently working on our first draft. So all the comments are very well appreciated. So the title of the paper is Dual Pricing in a Model of Sales, and that's the perfect audience to talk about model of sales. But I would really like to start by telling you what dual pricing is actually about. So dual pricing is a particular type of online vertical restraint. So by vertical restraint, I mean some contractual arrangements between the vertically related firms like manufacturers and retailers. And before telling you what dual pricing actually is, let me start by showing you what kind of vertical restraints we now observe in the online world. So that figure is taken from the Internet Commerce Sector Inquiry report by the European Commission. So what you can see here is a proportion of retailers with contractual restrictions, so that are depicted by these blue columns. And here you can see the ranking of different type of vertical restraints, the most popular vertical restraints. This is not a big surprise that one of the most popular vertical restraints
Anton, do you allow for intervention?
Sure,
yes,
absolutely.
I'm asking, I mean, when you talk about the proportion of retailers with contractual restrictions, who is exposing, or who is organizing these contractual restrictions? Are these the manufacturers, or
exactly.
or is that the platform?
This is the manufacturer, right? So I'm talking about the manufacturer imposing some restrictions on sales and on the contracts, basically. So what you can see,
but that is not necessarily then a restraint that is explicitly on online retailers. It could also be on offline retailers, right?
Absolutely right. Absolutely right. Yes, yes. So what you can see here, and which is not really a big surprise, is that one of the most popular vertical restraints is pricing recommendations and limitation. And this paper is not really about that. So instead, I would really like to confine your attention on the vertical restraints that is below the first line. So let me read them for you. So there are some limitations to sell on marketplaces where the manufacturer implicitly sell well. You cannot sell on marketplaces. There are some limitations to sell cross-border. There are some limitations to sell on own website. There are some limitations to use price comparison websites or advertiser line. Of course, we think that these vertical restraints are all different and have to be analyzed separately, but they have a common feature that I would really like to point out, is that it seems that in many cases, manufacturers try to limit sales through online channels. And this talk is going to be about dual pricing, which is a particular type of vertical restraint that is basically aimed at limiting online sales. So let me tell you what dual pricing is about. Dual pricing is a particular type of vertical restraints on online sales in which manufacturer sets different wholesale prices depending on whether its retailers sell online or offline, right? If I'm a manufacturer and I work with a hybrid retailers that are all active online or offline, I can sell, well, if you sell it online, you're gonna pay me 10 euros or $10. And if you sell it offline, you're gonna pay 5 euros. So that's the definition of the dual pricing. So we haven't seen dual pricing on the previous picture. And the reason is that this is completely illegal. So this is a hardcore restriction. That's what motivates us to start exploring this particular vertical restraint. I mean, we don't really know why this is a hardcore restriction. So what we read from the reports of antitrust authorities is that, well, since one of the main target and the goal of them is to promote online sales, and if the discrimination goes against online channels, that basically, in order to protect it, so this is made illegal. So there are cases of dual pricing from the past that I would really like to mention. So there are cases in 2013, 2 cases on Bosch, Siemens, and Gardena, in which the manufacturers, the firms, were introducing some price discounts for their products that were either proportional to retailers' offline versus online sales, and only those retailers could obtain full discounts if they sell offline rather than online. So they were basically motivating us to sell offline more often than online. The same thing is true for the case of Liggett in 2016, where retailers could only obtain the highest number of discount points through sales in offline stores, right? Nowadays, we don't observe it because it's hardcore restriction. So what we do in this paper, we try to nail down the key features of the environment, namely to have, online markets, offline markets, and vertically restricted firms, and try to explain why the manufacturer might want to restrain online sales. That's one goal. And the second goal is to say something about welfare implications of dual pricing, right? So let me just point out that this is a pure pricing paper. So we're going to talk about the double marginalization. So it's not going to be about investment or sales effort free riding problem. So this is going to be about pure pricing mechanisms that I'm going to present. All right, so what are the key features of the setup? So we consider a model of sales in a vertically related market based on Hall's paper, who is also in the audience, then Dale Stahl 98, and Martin's paper and Sandra's paper in AR 2015. So consider a manufacturer M distributing its product through two hybrid retailers, and they all operate online and offline. So some consumers are going to be searching online for free. So we say that they are quite price elastic. They easily compare prices and they buy at the lowest price. Others are going to use offline channel where search is costly, right? So we also assume that retailers cannot price discriminate across online and offline channels. So this is supported by the empirical paper by Kavala 2017 in AR, who shows that in many industries, in many sectors, we don't really observe a lot of price discrimination across channels. And what we are going to do in this paper is we're just going to compare two regimes. The regime of uniform pricing, where
can you just interrupt? I mean, just to
yeah,
it's perhaps, but just because we don't observe it doesn't mean that they can't do it. I mean, maybe they could do it, but find it, comfortable not to. Personally, I just don't see a good reason why you couldn't charge a different price on your website than on your physical shop. But anyway, go ahead.
No, I agree. In some industries, we do see that. So what I'm saying is that in that paper, so the guy Kavala collects a lot of price quotes in different industries, and he observes that it's not that often. I'm not saying anything about the reasons. That's what we observe, and we kind of follow these assumptions. I mean, if you want to introduce price discrimination, we would be fine with the main results as well. So this is not that important. So we're going to compare two regimes: uniform pricing, where manufacturer's tariff depends only on total quantity. So this is really a two-part tariff that consists of fixed fee and per unit wholesale price. And we want to compare it with a dual pricing regime, where manufacturer can condition its tariff on the resale market. Namely, the contract is going to be a triple consisting of the fixed fee and the per sale price in the online channel and in the offline channel, right? So that's basically the environment that we're going to talk about. So let me briefly tell you the main findings that we have in the model. So there are two types of the key results. The first is on optimal pricing, and the second, basically, strength of the result is about welfare implications. So first, we find that uniform pricing, right, the situation where you cannot discriminate across channels, cannot generate the profit of a vertically integrated monopoly, right? So for any two-part tariff that manufacturers set, there's going to be a price dispersion in the downstream market, and therefore the manufacturer doesn't have, powerful enough instruments to control the retail price. It can affect the price dispersion, but it cannot control the retail price, and therefore it's hard to soak the entire profit. So dual pricing actually solves this problem. So we see that manufacturer can discriminate against online sales in equilibrium. So, and the logic is the following. So in a model of sales, you remember the reason why we have a price discrimination is that firms always want to undercut each other until they reach the marginal cost, and then they set high prices. So in this case, manufacturer eliminates the incentives to undercut to corner the online market by setting high wholesale price online. So this restores certainty in retail prices. So we're basically going to observe a pure strategy equilibrium in the case of dual pricing in a model of sales. And therefore, manufacturer can generate a vertically integrated monopoly profit. So we see that dual pricing is actually a good thing for a manufacturer. We see it in equilibrium. Right. So that's one thing. And the second thing is about welfare. So we explore welfare implications of dual pricing in our model. First of all, we find that the wholesale price online in the case of dual pricing is going to be relatively high than in the case of uniform pricing. Then the price for offline consumers is going to be lower than the price in the case of uniform pricing. And this in turn has important implications on the downstream prices, on the retail prices. So what we do see is that, just a second, we do see that the price under dual pricing is always in between the highest price under uniform pricing and the lowest price in the case of uniform pricing. So ex ante, it's not really clear whether the ban on dual pricing would lead to higher or lower prices, and therefore we have to go for a full analysis.
But this is basically under the restriction that you have to charge one price online and offline, right?
Exactly, right.
Yeah.
As a retailer.
Yes, as a retailer, of course,
right.
As a retailer. Yeah.
Heskey, you have a question, right?
Yeah. So consumers here are homogeneous online and offline.
Yes.
Because I mean, I think I believe my and maybe others' first reaction would just be, this is just classic price discrimination. You've got different elasticity, different demand curves online and offline. And if we can price discriminate, then we know there's ambiguous welfare effects associated with price discrimination.
Exactly.
So, but that's not going to be your story.
This is part of the story, but I'm going to say something more. I'm going to say basically under which conditions we might have that dual pricing leads to higher or lower welfare. And this is that bullet point. So to sum up, in a very rough sense, what we find is that a ban on dual pricing leads to higher welfare if the pass-through rate of vertically integrated monopoly is large enough, if offline market has relatively high search costs, or offline market is large relative to online market. So we basically provide some condition. I'm going to be very explicit during presenting the model that basically under which dual pricing might be a good thing, right? But you absolutely agree that due to different elasticities, price discrimination could be a good thing, right? Correct. All right. So let me, for the sake of time, skip the related literature, and if you have any questions, I'm happy to answer them now, and then I will go to the model.
Just a quick question, because I think slipped by me a bit. You assume there's zero search costs online, right?
Exactly.
Do you find similar results if there are small but non-zero search costs online, or?
Right. So if you had some positive search costs online, then the model would basically result in a diamond paradox. That what you would have is a price equal to monopoly price in both markets, right? So therefore, it's not going to be any interesting, right? So we need to have some fraction of shoppers to basically generate some price dispersion.
But should we worry that you're making that fraction of shoppers be the online shoppers? Like, how would that drive these results?
What do you mean? Sorry.
So you might have some group of people who naturally are going to go to this firm anyway.
Yeah.
See it automatically, but we know that search costs online aren't zero.
Exactly.
So this was just more like, do you have a version where you add heterogeneity and allow for larger search costs?
So we had a version, well, not really a version, but we have a sort of extension in which consumers might have different search costs offline, but you always need to have a mass of shoppers, right? And that's the necessary condition to make a model of sales interesting, right? So
may I also ask, maybe add to Dan's question, just by slightly rephrasing it. So would it be important that everyone in online market are shoppers and everybody in offline market are not shoppers? If you had, say, different fractions of shoppers in online and offline markets, would that change the results?
Not really, because what is really important for me is that, oh no, wait, that would be something different. You're right, because then, because what's going on in my model, in that model, is that you can basically identify the types as a manufacturer and set wholesale price depending on whether it's sold to shopper or non-shopper. This is important. But if the market would consist on different fraction, I don't have a good answer to that. So, right. I mean, the main point of optimal pricing that I want to present would remain the same, because you wouldn't be able to get rid of mixed strategy equilibrium. But let me maybe come back to that point once I kind of present the model and it becomes more clearer, right? Okay, let me briefly tell you about the setup that we have. So consider a manufacturer M selling its product through two different retailers. So we normalize manufacturer's production cost to zero and retailers' retailing cost to zero. So retailers are a hybrid in a sense that they operate in online and offline markets. Retailers are going to set the same prices in both markets, so there's no price discrimination across online and offline channel. So online market, and this O stands for online, contains a lambda fraction of shoppers. They have zero search costs, so they easily compare prices and buy at the lowest price. If the price is the same, they are going to be split evenly between the retailers. Offline market B, so where B stands for brick and mortar, contains 1 minus lambda of non-shoppers. And following the standard assumptions, we are going to assume that first search is for free and second search cost S, which is higher than zero, right? So you randomly allocate it as a non-shopper at a particular firm, and then you observe the price there for free, and then you decide whether to buy or incur search cost and see the second price. All right.
So Anton, so
yes,
just to be clear, the assumption is then that all the shoppers are online and all the non-shoppers are offline.
Exactly, exactly.
But that seems indeed somewhat quite crude, no? So indeed, if you could have a different fraction of shoppers online than offline, that would indeed be better. But to have indeed this very crude, I mean, because this is almost assuming what you probably want to explain. No, because the price dispersion in a model comes from the interaction between the shoppers and the non-shoppers.
Correct.
And if you then, by having two markets, say that in one market everybody is a shopper and in the other it's a non-shopper, then then it's clear that you get rid of this price dispersion.
Exactly. Right. I agree. I mean, it's really hard to say what's going to happen once you have shoppers in both markets and non-shoppers in both markets. Right. So let me think about that maybe once I show you the main results on optimal pricing, and then maybe I'll come back to that point because we haven't thought about it before.
Anton, just quickly, lambda is exogenous, right?
Lambda is exogenous, right?
Okay.
Right.
Anton, Sorry, can I continue?
Yes.
The butting in.
Yes.
So this is, I mean, now Volker was looking ahead as usual, and I wasn't able to. But now this is really stark now that they can't discriminate, because if retailers now have all their captives in one place and all their shoppers in another place. So now they can just say, well, you can pay the monopoly price and we can marginal cost compete, Bertrand compete with these guys. Because now they can, models of sales were supposed to be founded in the idea, I think, that a retailer couldn't tell the difference of what person you are when you came in. Are you just looking at me, or are you looking at a competitor as well?
Right.
But now I can just set one price on my website, that's where the shoppers go, and one price in my brick store, and that's where they go, and that's it. So now this gets really stark, right?
Right, I agree with that. Although at the same time, I mean, the fact that you sell offline and online might also tell you something about the search costs. I'm not saying that shoppers do not exist in the offline market. I'm just saying that maybe it's not that bad assumption to think that search costs are a little bit higher offline rather than online, right? And that's basically all we need for the main point. Although we don't really model that there are some shoppers offline, so I agree. So right, but I somewhat agree with what you're saying. So all right, so let me just continue so that you basically see the model. Otherwise, it would be a bit pity. So in order to introduce double marginalization problem in the model, we assume that each consumer buying at price P demands D of P units, where D of P is going to be strictly decreasing function, and it's continuous with its derivative. So the revenue goes to zero when price goes to infinity and goes to zero. So that gives us the existence of equilibrium. And the only assumption that we're really going to make on that function that we need for our results is that D satisfies the Marshall's second law of demand, which says that the absolute value of elasticity is non-decreasing in price. So this is a little bit weaker requirement than log concavity. And this is sufficient to prove that the monopoly profit of a retailer facing the wholesale price W is strictly quasi-concave, and therefore there exists a unique monopoly price that we are going to denote as PM of W. So just a piece of notation that I really want to emphasize and that they're going to be using a lot is define per consumer industry profit as R of P, which is basically the profit when the cost is equal to zero. And then define P0 as the vertically integrated monopoly price. So this is the price that the manufacturer actually wants to impose in the downstream market. And R0 is going to be associated profits. So manufacturers' contract to the retailers is going to be a triple consisting of three numbers. So it's going to be public. So both retailers are going to see, consumers and retailers going to see the contract, and this contract is going to be non-discriminatory. So under uniform pricing, the wholesale prices must be the same. So the contract is going to be a two-part tariff. Under dual pricing, there is no such restriction. So let me be very precise with the timing of the game. So manufacturer offers this triple, which is observable by retailers and consumers. Then retailers simultaneously decide whether to accept the contract or not. Then each retailer observes whether the other retailer accepted. So this is made for simplicity. And then retailers simultaneously set prices, and consumers make search and purchasing decisions in the last stage. So equilibrium concept is perfect Bayesian equilibrium in which consumers hold passive beliefs. All right, so let me tell you something about the optimal pricing. So I'm going to show you the equilibrium under uniform pricing, and the main goal is basically to show that under uniform pricing you cannot generate the vertically integrated monopoly profit, and then I will come to dual pricing. All right, suppose that...
So Anton, so the consumers, they observe the contract also.
They observe the contract, right? So suppose that manufacturer offers two-part tariffs. So I start by analyzing uniform prices. Then following Stahl's result, there's not going to be a pure strategy equilibrium due to undercutting incentives of the firms. So in equilibrium, retailers, I'm just going to sum up what's going to happen in equilibrium. So in equilibrium, retailers place a mixed pricing strategy F, which is continuous on its support from the lower bound to the upper bound. Non-shoppers never search on path. So if we define the maximum expected gain of search as function H, that depends on the upper bound of the distribution, it must be the case that in equilibrium, this maximum expected gain of search equals search cost, or if it is lower, then the upper bound must be the monopoly price. So this is a necessary sufficient condition for equilibrium. We don't make any assumptions that would ensure monotonicity of this function H, which is the expected gain of search, as for instance, Stahl did. So we might have multiplicity of equilibria in the model, but the important thing is that there's no pure strategy equilibriums. Due to the multiplicity, we basically are not going to, we're always going to have price dispersion in the retail market. So the manufacturer's problem is the following. So the expected profit of the manufacturer setting W is just going to be expected industry profit, where expectation is taken with respect to the prices paid by consumers, right? So 1 minus lambda fraction of non-shoppers pay just price they observe first, and others shoppers, they pay the minimum of prices. So since this function is continuous, we're going to have the existence result. So there's going to be some optimal W, which is going to be higher than 0 in that model. And we know that there's going to be a price dispersion. So that comes the first proposition. Any two-part tariff, W and T, cannot generate the profit of vertically integrated monopolist. So an integrated monopoly would like to set just one price, which is P0, right? And any wholesale price leads to price dispersion. Therefore, it cannot really control the price, realized price, but only the dispersion in the downstream market. And therefore, P0 cannot be induced due to mixing behavior inherent to the model of sales. That's kind of the main thing to point out. So this statement is really true for general continuous nonlinear tariff, for general distribution of search costs once you have a fraction of shoppers, more than to retailers and endogenous access to the online market. All right, so let me show that under dual pricing, you can actually restore the efficiency and the manufacturer can get vertically integrated monopoly profit. So I'm going to briefly show you how the equilibrium looks like, but without going any details for any W and WB. So I'm going to consider 3 cases. In the first 2 cases, there's going to be always price dispersion, and the third case is going to be something that we are actually interested in. Suppose first that WO is lower than the monopoly price of WB. In that case, the incentives are really, really similar to standard Stahl model. We can prove that there's no pure strategy equilibrium due to the same reason, that if there's one, firms want to undercut, and then once they reach the bottom, they want to play something higher, as in the standard model of sales. We're going to construct an equilibrium which is continuous and where non-shoppers never search on path. The reason why I say construct is because I'm talking about the existence. So I have to show the existence of equilibrium. So if you write down the indifference condition of the retailer for any price and the support and solve it, then you could have the distribution of prices given by formula 5, and it can be shown that this is indeed a probability distribution as this function is increasing. So this is basically the Stahl model with different production cost, marginal retailer cost. All right, and then the same logic as we had before is true here. You can define the maximum expected gain of search, and to show that at the upper bound this must be equal to 0, or otherwise the upper bound is equal to the monopoly price. So the important thing is that the downstream market is characterized by price dispersion again, and the manufacturer earns less than R0. Okay, so the second case is a little bit different in a sense. So basically the second case is when WO is higher than the monopoly price of WB. So in that case, you somehow want to keep prices low to rip off non-shoppers, but at the same time, you don't want to keep it too low, because in that case, you will have to sell to shoppers and make losses from that. So here we have two sub cases. I'm not going to go into all of the details, but I just want to say that if you define W tilde as the average price, wholesale price paid by retailers that serves all shoppers, then there is going to be a pure strategy equilibrium under the condition that WO is lower than the monopoly price of W tilde. The important thing is that in that case, the manufacturer won't be able to generate monopoly profit again. So basically, continuing the second case, if this condition is not true, there's going to be a mixed strategy equilibrium, which is a little bit non-standard, which is reversed to a style model, in which basically firms are going to mix continuously on some interval. They might have mass points at the upper bound, and non-shoppers would randomize at the upper bound. So here's the intuition is the opposite, basically. You want to undercut to get more money from non-shoppers, but you want to increase the price to get rid of shoppers, basically. In that case, you also get mixed strategy equilibrium, and you're going to make less than R0. And the third case is the most interesting one. So this is the case where WO is exactly equal to the monopoly price of WB. So in that case, you don't want to set a price lower than WO, because in that case, you will make losses from shoppers. You always want to set higher prices. At the same time, you don't want to set prices higher than the monopoly price of WB, because you can decrease it, you can slightly undercut your rival. So the only equilibrium in this case is where the price is exactly equal to WO equals to the monopoly price of WB. So if you set wholesale prices in that manner, that would allow you to basically generate the profit of the vertically integrated monopoly. And we show that this is, so this basically, this contract P00 is basically going to generate the monopoly profit. And this is a unique equilibrium under dual pricing. So the intuition here is that manufacturer wants to discriminate against the online sales in order to eliminate these undercutting incentives of the retailers and eliminate price dispersion by squeezing the gains of undercutting in the online market. Right, so that's what we have. And let me just show you one picture on comparative statics for the linear demand. So what you can see here is, first of all, the wholesale prices for different level of search cost. So in the case of uniform pricing, the blue line represents the optimal wholesale price. If we go to the dual pricing, then the price in the online market is going to be higher than that. And in the case, and basically for the offline market is going to be equal to 0, which is lower. This in turn results to non-trivial comparison of prices, in which we basically have that for low search costs, for instance, here, the average price paid in the case of dual pricing is higher. But if search costs are really high, then the average price paid in the case of uniform pricing, the blue line, is actually going to be higher, right? So this sort of motivates the welfare analysis that I'm going to, so if you don't have any question that I'm going to talk about next. Right, so for the welfare analysis, we have some asymptotic results for small s and for high and low lambda. And then we have some global results for k-linear demand. All right, so let me start by showing you so let me start with some preliminaries. So we're basically interested in welfare effects of banning dual pricing. So define delta consumer surplus as the difference between the consumer surplus under uniform pricing and dual pricing. So if delta consumer surplus is positive, it means that a banning of dual pricing is actually a good thing for consumers. So, and the last piece of notation is the following. So define alpha and beta such that alpha is the vertically integrated monopoly cost pass-through rate at cost equals to 0, and beta is the derivative of the pass-through rate. So these things are crucial for the results, and you will see that actually a lot of the limiting result will depend on the pass-through rates and the behavior of the pass-through rate. All right, so let me show you the first results for small s. So it turns out that for small s, the difference in consumer surplus can be approximated in the following way. So where delta consumer surplus, where the sign of the change in consumer surplus is going to be just determined by that number. So which depends on the pass-through rate and the behavior of the pass-through rate. So what we see is that when S is small, then consumer surplus under uniform pricing is higher if this number is positive, right? So this is a necessary and sufficient condition, but an easier sufficient condition that we were able to obtain is that consumer surplus under uniform pricing is higher if alpha, which is a pass-through rate of costs, is less than 2, and beta is negative or equals to 0, right? So basically, so beta again is the derivative of the pass-through rate, so it's quite natural to expect that this is going to decrease with respect to costs. And another thing that we were able to obtain is that regardless of the function, of the demand function, we obtained that banning dual pricing is always a good thing for the online market, but it's always a bad thing for the offline market, right? So for the total welfare, the result is really the same, where instead of comparing the pass-through rate with 2, we have to compare the pass-through rate with 1. So if pass-through rate is lower than 1 and beta is less or equal than 0, then we have that uniform pricing is actually a good, the banning of dual pricing is a good thing. All right, in fact, we might have some examples under which dual pricing is actually good for welfare, right? So let's consider the k-linear demand function that is given by that formula. So this is the demand function that gives rise to a constant pass-through rate, alpha, that can be easily computed, which is 1 over k plus 1, where k is the parameter of the demand function. So this is constant, therefore the behavior, the derivative of it is equal to 0. So, and this particular example can generate all possible cases, namely that if for small s, a ban on dual pricing might lead to lower consumer surplus and lower total welfare if k is between -1 and -1/2, or if k is positive, that basically banning of dual pricing might lead to higher welfare. So we basically show that for small s, different things are possible. But if pass-through rate is high, then dual pricing is most likely to be good for consumers and total welfare. All right, so I'm gonna skip 2 slides of how we actually solve this. And I'm going to show another asymptotic results for small lambda, where the fraction of shoppers is really small. In that case, we had to derive the 4th order approximation of consumer surplus to get the true sign of the difference. So, and then we actually obtained a clear-cut result, namely that regardless of functional form of demand, we have that consumer surplus and total welfare are higher under dual pricing, provided lambda is sufficiently low. And we find that this is purely given by the effect on non-shoppers and the effect of offline market. And the effect of shoppers is really negligible because lambda is really small, right? So if lambda is very, very high and close to 1, we also could approximate the change in consumer surplus in a very non-standard and non-expected for us way, having a logarithm here. And here the result is less clear-cut, I would say, and depend on this number zeta, right? That also depends on the derivative of the pass-through rate. So these are all kind of important for determining the sign. And depends on the reciprocal of the pass-through rate and the global reciprocal of the global pass-through rate, right? So there's no clear-cut prediction, but we can say, for instance, that for K-linear demand, we observe that consumer surplus and total welfare are higher under dual pricing. Right, so that was something about asymptotic results. Let me tell you something about a global result that we could obtain for K-linear demand function and high search costs. So from Simon's paper and paper of Regis Renault, we know that the ratio between the monopoly profit and consumer surplus, the ratio between the monopoly profit and consumer surplus is equal to K plus 1. So this is for K-linear demand. We were able to show that this is also true in the model of sales. So we basically, when search cost is really high, and since under uniform pricing, the profit of the manufacturer is always lower than the vertically integrated monopoly profit, it implies that consumer surplus under uniform pricing is also lower than consumer surplus under dual pricing. So what we have is that for K-linear demand, a ban on dual pricing strictly reduces profits, consumer surplus, and an aggregate surplus. And I also wanted to show you some simulations that I made for linear demand and different search costs, where search costs are actually not that high. So what we can see here is that consumer surplus, so the green line represents the consumer surplus in case of dual pricing. So around the blue line represent consumer surplus with respect under uniform pricing. So on the horizontal axis, you have search costs here. So what you can see is that for low search costs, consumers are better off under uniform pricing, but they're worse off if search costs are high, right? So we haven't proved it, but we, as an observation, I just wanted to say that a ban on dual pricing reduces total welfare and consumer surplus for high enough search costs where the cutoff really depends on lambda and where the cutoff increases with respect to lambda. So our results can be also useful for basically for the comparative statics in a model of sales, right? So in the vertical relation version of the model of sales, so basically in the variant or style model, increase in search cost always, or decrease in fraction of shoppers always lead to higher prices, lower consumer surplus, and lower total welfare. So in the vertical relation version of that model, and that's basically what we want to point out, is that this might not be true. So the standard comparative statics of the model of sales might be completely different. And the reason is that the manufacturer is going to adjust its wholesale price. So first thing that we note is that consumer surplus and total welfare are non-monotone in the fraction of shoppers. We know that when there are no shoppers or all consumers are shoppers, in that case, there's no price dispersion, there's no problem. So basically manufacturer is going to induce P0 in the equilibrium and consumer surplus is going to be the same. But we also show that consumer surplus is decreasing in a small neighborhood of lambda equals to 0. So therefore, at some point, it should be increasing. So there's some non-monotonicity. When talking about search costs, so we don't have a clear result that it's always non-monotone in search costs. But for instance, for k-linear demand, we show that for high search cost, basically consumer surplus with price dispersion is always lower that under basically dual pricing, and in that means that we might have that consumer surplus increase at when S is really low and then decrease when search cost is very high. So this is basically what we observe here, right? So some non-monotonicity of consumer surplus with respect to search costs. So right, so I have 2 more minutes. So let me briefly tell you that, so one small extension that we also worked on is basically the extension on secret contracts, where retailers don't really observe the contracts of each other. In that case, if search cost is really high, and if we focus on contract equilibrium in the sense that we don't really consider double deviations of the manufacturer, so the manufacturer cannot secretly change both contracts, in that case, the main result of pricing remains the same. Otherwise, if we look for perfect Bayesian equilibrium with passive beliefs where a manufacturer can simultaneously change both prices, this would, in that case, we don't really know whether the equilibrium exists in that model. All right, so I have 1 minute, so let me conclude then. Okay, so in this paper, we explore the welfare implication of dual pricing on offline and online distribution channels. So we see that dual pricing solves the inefficiency created by price dispersion, and by discriminating against online sales, the manufacturer can destroy this mechanism that is inherent to the model of sales and can reach the vertically integrated monopoly profit. That was something about our results on prices. Then we identify conditions under which consumer surplus and total welfare can be higher under dual pricing. And what we find is that if offline market has relatively high search cost, is relatively large, and the pass-through rate is sufficiently high, then discrimination against the online market can lead to higher consumer surplus and total welfare. So, but of course, these results all depend on the size of the search cost, fraction of shoppers, and the pass-through rate. All right, so thank you for listening. And so I'm happy to answer the questions if you have some.
Feel free to ask questions as they come to you.
Right, so
maybe I can start maybe with one question. I mean, going back a little bit to what was said earlier about the separation of shoppers and non-shoppers into online and offline markets. I think generally you also would like to say something about the importance of offline markets relative to online markets. But now in your model, this is exactly the same as the share of lambda, because if lambda decreases, then essentially the share of the online market becomes very small. And so I think generally you want to probably separate them and be able to think about what is the impact of a different fraction of shoppers on the online market, and then also to think about the relative importance of online sales relative to offline sales, because these seem to be somewhat different things, but in your model they are one-to-one the same, because shoppers is simply the fraction of the online market.
Right. Right. So considering the first point, so you mean to make the size of the total market more flexible rather than one, right? To be able to, change the fraction of shoppers, keeping the same fraction of non-shoppers, for instance.
Exactly. So then you need to have different ways of measuring the
You're right.
relative. Yeah.
You're right.
Because now these two things, they go one-on-one.
Right. No, I agree with that.
So let me just interject here. So I think in principle, we could look at a model in which there are non-shoppers, both online and offline. I think it shouldn't be too hard to show that, if the share of shoppers is higher online than offline, then the manufacturer still wants to discriminate against the online market, right? I mean, at least by continuity, this should work here. I would expect that to be provable. I think what would be hard to do is any kind of welfare analysis.
Yeah, exactly.
Right? And because if prices are dispersed both with and without dual pricing, the welfare comparison is going to be hard. So I'm not sure we would be able to do that, right? But just in terms of showing that discrimination against the online market is optimal, I mean, that should be feasible. Yeah.
Right.
Kind of continuing on that, shouldn't it be more natural though that you should have mixing with and without, right? Like in these types of models where you get price mixing somewhat intentionally, unraveling that has a kind of inherent cost, I feel like, that it wouldn't in another model maybe.
So you mean mixing with and without, you mean?
With dual, like if you had, I think.
Right.
Yeah, what was just being
said.
So
exactly. So, right. So for instance, if you focus on linear tariffs, but not two-part tariffs, so you basically have mixing under dual pricing as well. So we haven't analyzed it completely, but what we do see numerically is that under linear contracts, the wholesale price online is actually going to be the opposite intuition. So in that case, the wholesale price online is going to be lower, because in that case, you basically want to intensify competition between retailers, and therefore you want to incentivize undercutting incentives of the retailers, leading to the opposite kind of result. Right. But here you're right. So for some, for some wholesale prices, you have mixed strategy. You basically have mixing, right? But what we do observe is that in the optimal case, there is only pure strategies. Right. Any other questions?
I was going to suggest, I have a comment, not really a question, but the interesting observation is that firms don't price discriminate as much as they should. That is, as much as our models predict they should. And it's a bit of a mystery why that happens. For example, there's a recent paper by Della Vigna and Genkaus that looks at chain pricing. So McDonald's prices, for example, they're really almost uniform across the entire country, even though there were millions of dollars more profits to be made if they price discriminated. Right. So I wonder if there's any way to think of your model as a model of why they are able to price discriminate, but don't do it as much as they should, or as one would expect.
Right. I mean, in fact, we could assume that retailers do price discrimination in the model. In that case, we would still get the same prediction that manufacturer would not be able to generate the entire profit if there is a price discrimination. But in that case, the model would be quite trivial. We cannot really say much why they do this, why they don't price discriminate by the means of that model. I mean, one And I don't have a good explanation why this actually happens. So one explanation might be that you don't really want to irritate consumers too much, and you don't want to show different prices because consumers might think that you just manipulate them. Because now it's really simple to, to take your cell phone from the pocket and check the price in the online, basically in the internet. And I'm not sure that you really want to play with this somehow. Maybe that's part of the reason why we don't really observe that much price discrimination. And well, instead, of course, right, yeah.
Yeah, so we're taking this as given. I mean, so there might be some sort of reputational loss to price discrimination. We are taking that as given. I mean, you might wonder, so would there be some commitment benefits, so sort of to committing not to price discriminate? I mean, in this model, retailers always end up making zero profit, so that doesn't really happen.
Yeah.
So I don't think that's a model for explaining why price discrimination does not happen. We don't have anything interesting to say about that here.
Yeah, it's just as a funny observation. It seems that in your model, these retailers, they have an incentive to put on their website some code and set a message. If you get with that code to a physical store, you will get a discount. By doing that, you can redirect from one retail channel to another retail channel and avoid paying higher wholesale price.
Right. I agree.
Yeah, it's just another
exactly. So
marketing strategy.
Right. We don't. Yes. So right.
So there is a large literature on this, right?
Yeah.
Which we are staying away from.
Exactly.
I see.
Right. All right.
Okay, I will cut the recording here, and anyone who has further questions, feel free to continue to ask them.